Like terms. Like terms are terms with the same variables that are each raised to the same powers. Only the coefficients in like terms may be different from each other. So let's take a look at some examples. 4x squared y is a like term to 2x squared y. You have the same variables, x and y. The x is raised to the power of 2 and the y is raised to the power of 1. Over here we have 3xy squared, which is a like term to 2xy squared, because again, we have the variable x and the variable y. X is raised to the power of 1 in this case, and y is raised to the power of 2. It's okay that the coefficients are different in this case and in the case before, because the variables and their powers are the same. However, 2x squared y is not a like term to 2xy squared. Even though the coefficients are the same and both have x and y as variables, in this term over here, x is raised to the power of 2, and in this term over here, x is raised to the power of 1, and the y's have different powers as well. So these two are not like terms to each other. Let's try some examples. Which of the expressions below are like terms to the monomial 10abc? Drag and drop into the appropriate bucket. Well, obviously we're not going to be dragging and dropping here, but we want terms that have the variables a, b, and c, where a is raised to the power of 1, b is raised to the power of 1, and c is raised to the power of 1. The coefficient can be whatever it is. That does not matter. So let's take a look. We have 7abc. We've got a, b, and c. The variable is raised to the power of 1. So that is a like term to 10abc. 10a cubed does not have the same variables as 10abc, and the a is raised to the power of 3, which is not the case in our monomial. So that is not a like term. abc, we have the three same variables. They're each raised to the power of 1. And even though there's no coefficient, that doesn't matter. The coefficient can be whatever it wants to be in like terms. So that is a like term to 10abc. And AB is not a like term because we're missing the variable c. So that is an unlike term.